In this class, now I am going to explain you meaning of a simple pendulum, motion of a simple pendulum, and time period of a simple pendulum. First, let us see the meaning of a simple pendulum. Take a metal bob. See, this is a bob which is made up of with a metal, so which looks like a small sphere, and suspend this metal bob with a thread and attach this suspended metal bob with a rigid support. Let us take this point as S. So this is a simple pendulum, a suspended metal bob which is attached to a rigid support is said to be a simple pendulum. And let us take the length from the center of the bob to S is called length of the simple pendulum. The distance from here to here is called the length of the simple pendulum. Now I am pulling this bob to here and I am leaving. What will happen? So here till here we have brought and we left like this. So it moves to here and again it returns to here. So here it may reaches to maximum distance up to here, and started from A and up to here it is reached to B. So about this position it moves like this. So it reaches to B, again it reaches to A about this position. This is the original position which is said to be mean position. So moving towards A, that is to, and coming back to A, pro. This to and pro motion is called an oscillation. To and pro motion is called an oscillation. So this is also called an oscillatory motion. See, connect this S to A, connect this S to B. Let us take this angle is theta. See students, in this observe the bob at any point. Now bob is at B. I am taking this point, wherever you take, but I am taking at this point B. On this bob there are two equal forces are working. So one is acting towards the earth due to the gravity. So that is called weight of the bob, which is equal to mg. And one more force which is equivalent to this works towards S in the thread. That is called tension, or you can call it as tensional force. Both are equal, working in opposite direction. This is working toward the earth and this is working towards S. Both are equal. This is tensional force, this is gravity force, weight like. Okay, so you know this. Both are equal and working opposite direction on the bob. Hence this journey is possible in this direction. And we resolve this weight force into two components. One is working this side, so that is equal to mg cos theta, and one more is working this side, that is mg sin theta. So due to this mg sin theta, this force only, so this force which brings this bob to the mean position. So this force always tries to bring this bob into the mean position. Okay, remember that point. Okay students, now I am going to connect this AB arc like this, so that I got a circle. Okay, students, have completed one rotation. Now one circle is formed. So see, as I said to you, this is oscillatory motion. Now this is the part of a rotatory motion. How this bob comes into the motion? By applying the external force on it. We brought to here, na, we pulled and we left. Means external force acted on it, na. So whenever the object is there in the rotatory motion, so torque works on the object. You know that torque is equal to torque, which is denoted by the letter like tau. So that is equal to R into F. Okay, so on the bob, external force is applied. It is there in the oscillatory motion, but it is a part of rotatory motion. So now that torque is equal to Rf in the rotatory motion. But in this case, this R equal to, this is R, radius of the circle. But R is equal to how much here? Length of the simple pendulum, L. But what is F? Torque which works in this direction, but force is working in this direction. Okay, both are opposite in this case. Hence, in the place of F, I am going to write minus mg sin theta. Minus I would like to keep here, and mg sin theta. I hope you have understood this. Torque which works in this direction, and bob is trying to come towards the mean position because of this force. So both are in opposite direction. Hence I wrote minus. Here minus mgl sin theta you got. So here this is very small. Sin theta is very small. Hence I want to consider the sin theta as theta, approximate value. Because this is a very small quantity, hence you can replace sin theta by theta. So now if I replace sin theta by theta, I get minus mgl theta. But you know, students, in the rotatory motion, torque is equal to product of momentum of inertia into angular acceleration. What is alpha here? Angular acceleration. Now both are same, left side quantity. Now equate the right side quantity. So I alpha, I means momentum of inertia, alpha means angular acceleration. Now we equate both of them. I alpha is equal to minus mgl theta. Now send this I to the right side so that you will get alpha is equal to minus mgl by I into theta. Now observe here, m means mass of the bob, g means gravity, gravitational law, so acceleration due to gravity, L length of the simple pendulum, I momentum of inertia. So all these are constants, so it is a numerical, but this alpha and theta are variables here. Now this alpha is directly proportional to, so alpha is directly proportional to minus theta. See here, don't get a confusion between these two. This is proportionality symbol, this is angular acceleration. Observe the difference here. So alpha is directly proportional to minus theta. Okay, students. Now this motion is said to be simple harmonic motion. Why? Because here acceleration is directly proportional to the displacement. In opposite direction you got. You learned the definition of simple harmonic motion. When do you say a motion is said to be simple harmonic motion? Whenever it makes to and fro motions and acceleration is directly proportional to the displacement in opposite direction. Sign should be minus. Okay students, you know the definition of simple harmonic motion. Whenever the object in a to and fro motion and angular acceleration is directly proportional to the angular displacement, then that object is there in the simple harmonic motion. Hence, so in this case, this bob is also following the two conditions. It is there in to and fro motion, and acceleration is directly proportional to the displacement in opposite direction. But here acceleration is called angular acceleration because it is under rotatory motion. Hence we have to use the word angular acceleration. So here displacement is theta. Hence, so what you people have to call this motion of the simple pendulum? It is a simple harmonic motion. Okay, I hope you have got it. Now, see, students, but you know what is alpha here? Angular acceleration. Angular acceleration of an object under rotatory motion, alpha is equal to angular acceleration performed by SHM is equal to minus omega square into theta. You learned this. What is alpha? Angular acceleration of a body which is performed simple harmonic motion is equal to minus omega square theta. Okay. Now equate these two. This is alpha, this is also alpha. Now I am equating these two. If I equate these two, what do I get? So here minus omega square theta, which is equal to minus mgl theta by I. Minus minus cancel. Theta cancel. Now omega square is equal to I got mgl by I. Okay students, I think up to here you have got it. Now see here. What is omega? You know. Omega means what? Angular velocity. See, if you take an object here and if it completes, see here, what is this? Distance covered by this object. So, it has some velocity, that velocity is denoted by the letter omega, angular velocity. So, velocity, how do you get? Distance by time. See here, this is distance covered by this object which is there under the rotatory motion. How much distance covered? On complete rotation, 2 pi radians. Okay, distance, angular, here, angle, see this is distance covered by this object. So how much angle is it making at the center? 2 pi. So that is angular displacement. Angular displacement is how much? 2 pi by t. T means time period. Okay na students. So in this simple pendulum case, how do you define a time period? Time taken by the bob to complete one oscillation, one to and fro motion. So that time period only we are going to derive here. So but here in this case time period t. So now in the place of omega, in the next step I am going to write 2 pi radians by t. I think you have got why I am writing 2 pi radians by t. This is called angular velocity. Actually velocity is equal to distance by time na. So here in the place of distance you have to write here angular displacement. So that is 2 pi radians, one complete rotation by time period t. Now send the square to the right side. So square root of here mgl, but I is equal to how much? Momentum of inertia. So I is equal to m into r square. You know this, momentum of inertia. Now m into r square, but here r is equal to how much? Radius of the circle, that is L here, length of the simple pendulum. L into L. LL cancel. Now in place of omega I want to write 2 pi radians by t. So which is equal to root of, here what I got, mm also cancel, one g by L is left. Now take the reciprocal on both sides, t by 2 pi radius which is equal to root L by g. Now send 2 pi radius to the right side so that we will get time period is equal to 2 pi radius into root L by g. Okay students, I hope you have understood. Time period of simple pendulum is 2 pi radian into root L by g, where L represents length of the simple pendulum, g acceleration due to gravity. Okay students, so you know the meaning of a time period, time taken by the bob to complete one oscillation. So sometimes this bob may take to finish this oscillation in 2 seconds. Okay, so if it is done this oscillation in 2 seconds, then that pendulum is known as seconds pendulum. Whenever the bob takes 2 seconds time to finish one complete oscillation, then that simple pendulum is said to be seconds pendulum. Remember this point. So this is the meaning of a simple pendulum, and whose motion follows simple harmonic motion, and whose time period is 2 pi radius into root L by g. So I think we have understood my class. Thank you students, thank you one and all. I am requesting you to subscribe, like and share my channel so that my classes reaches to many people. Thank you one and all.